reactions and equation. Chapter 1 chemistry. So let's have it. Waiting for a few minutes to get ready with my equipments. So here most probably all of you are preparing for your exams, and already you may be ready with all the chapters. This is a simple chapter where you can have a quick revision, and that too very simple. So let's start out with the thing. I'll move with the chapter along with the basic things. How you come to know that chemical reaction has taken place. So what is chemical reaction? The reaction in which reactant react to form product is called chemical reaction. So in this you can see here. Okay, so if you can recall it like how we come to know that chemical reaction has taken place. So for that, few basic things, like if milk is left at the room temperature, we know that the milk gets spoiled. And the same way, if iron tawa is exposed to atmosphere, it get rusted, grapes get fermented, food get when the food is cooked. So all these where we cannot reverse back the original content, we call it as like a chemical reaction. So we say like chemical reaction has taken place. Now coming to the next topic, like all the above situations, the matter and the identity of the initial substance does not change, so we call that to be chemical reaction. Now you may perhaps be wondering as what is actually mean by chemical reaction. So here with the four you can see in this activity is very important. Very often they ask like what happens when magnesium ribbon is burnt. So here this is the activity related to burning of magnesium ribbon. So magnesium ribbon, when it is burned, it is a hexothermic reaction. Magnesium will react with oxygen to form magnesium oxide. It's an oxidation reaction. Moreover, lot of light and heat is produced. Here the magnesium ribbon will burn with white dazzling flame. So what is this dazzling flame? Dazzling means when the crackers are burnt, we get a white color flame. So that is called white dazzling flame. So the magnesium ribbon burns with white dazzling flame. So what kind of reaction we can call it? There are two names we can give. The first one we can call it like oxidation reaction, or the second one we can say it to be like hexothermic reaction as heat is produced. So out of this page you need to learn this activity very properly. Now coming to the next page, so yeah, once let's recall it. You must have observed that magnesium ribbon burns with white dazzling flame and changes to white powder. So that powder is nothing but magnesium oxide. Now the next activity is also very important. So here the next activity, zinc granule, formation of hydrogen gas by the action of dilute sulfuric acid on the zinc. So when sulfuric acid is added to zinc, zinc will convert into ZnSO4 plus hydrogen is liberated. Zn plus H2SO4 will form ZnSO4 plus H2. So here hydrogen is liberated. So here this activity, so they have taken few zinc granules in a conical flask, then they tested with it either hydrochloric acid or sulfuric acid. Now this to be handled very carefully as the student is dealing with the acid. So now this is like hydrogen is liberated. When hydrogen gets separated from a substance, we call it as oxidation. So that we come across in the last of this chapter. So in this chapter, basically what you need to prepare. The first one, how you come to know that chemical reaction has taken place. So these 4 points are important, like change in state, change in color, evolution of gas, and change in temperature. Whenever you observe that these 4 events has taken place, we conclude that chemical reaction has taken place. So here this can be one of the question. And what is chemical reaction already we discussed. Now how to represent a chemical equation. There are 3 methods to represent a chemical equation. So what is a chemical equation? Where the reactant react to form product is called chemical reaction. Now how we come to know that chemical reaction has taken place. So for that, here like the substance getting changed. Okay, there are 2 kinds of changes. One, it can be physical change, another can be chemical change. So what is physical change? When the original identity does not change, we call it as physical change. When the identity of the substance changes is called chemical change. So here when we took the example of magnesium and oxygen, here you can see magnesium and oxygen, they are reacting to form magnesium oxide. So the identity got changed. Magnesium and oxygen both are elements. Now there is a formation of compound. So as the identity of the reactant and product change, so it's a chemical reaction. Now the next topic, how to write chemical equation. So as is a quick revision, so I'm going a little faster. Just you'll be recalling back the chapter. So as you're just before your exams, mostly many of you are preparing for your board exams or pre-board, and some of you for the class test and all. So it's a quick revision. Now coming to the chemical reaction, how to represent it. A chemical reaction can be represented either in the form of sentence, like the same equation how we can write. When it is in the sentence form, we'll be writing the sentence magnesium reacting with oxygen to form magnesium oxide. That is one way to represent. Second one, we can represent them in the form of word, as that is given in the blue words. Magnesium plus oxygen is forming magnesium oxide. And the next one, third type, where we will be representing it in the form of symbols. That is symbolic representation. We can represent any chemical reaction in three different ways. The first one is in sentence way. The second one in the first one is sentence formation way. Second one in word form. Third one in symbolic form. So here the last one is symbol, magnesium plus oxygen forming magnesium oxide. Now the next one, what is called balanced chemical equation and why it is important. So here when we count out, the reaction is represented where the products are written on the left side and reactant on the right side. If the left side and right side, both the numbers are same, okay, when we count out the elements numbers, if they are same, we call this to be balanced chemical equation. So why balancing is important? As per the law of conservation of mass, mass can neither be created nor it be destroyed. To satisfy that, chemical reaction has to be balanced. So here we are balancing to satisfy that law. Now when the reaction is unbalanced, generally when we write a raw equation, unbalanced equation, that is called skeletal chemical equation. Okay, what is skeletal chemical equation? Unbalanced equation is called skeletal chemical equation. Now balanced, like we'll be counting the numbers of element present on the left side and right side, and always while balancing we can put the numbers only as a coefficient. It should neither be kept as subscript or superscript, that you need to remember. So how to balance? So let's start out with one example. Here the zinc is reacting with H2SO4 to form ZnSO4 plus hydrogen. As I told, like while balancing, we will count out the number of elements present on the left side and right side. Then we balance it. So here the zinc in the left side is 1, whereas ZnSO4, again the zinc is only 1, whereas hydrogen is 2, and right side hydrogen is 2, SO4 only 1. So both the side it is balanced. We need not to balance. Already this equation is balanced equation. Now the one more example is there, Fe plus H2O, it forms Fe3O4 plus hydrogen. So this is the reaction of rusting. So here when we count, 3 iron is there, right side, whereas left side only 1 iron atom is there. Hydrogen is 2, left side, and right side also it's 2, it's balanced. Oxygen is imbalanced, oxygen is 4 towards right and 1 towards left. So we'll be putting 4 in front of water to balance it. Now when we put 4 in front of water, water will get balanced, and then 3 we need to place before iron. So let's see the solution here. Now when they counted, as there was mismatch, so finally you can see here 3 is placed before iron, as iron Fe3 it was 3, and oxygen 4, so we placed 4 before water. You can see here 4 is placed before water to make the oxygen balance. So whatever the highest number will be there, we need to start balancing from there. So this is we completed. Now after balancing, how we can make chemical equation much more informative. So here we can make equation more informative by balancing, by writing the physical states of the element. So here the physical states of the element can be written as liquid, solid, or physical states can be written as liquid, solid, gaseous, aqueous. So in that way we can make the chemical equation to be more informative. By writing the physical states of the element, we can make the reaction to be more informative. Then the next one, you can see in the reaction here, carbon monoxide, CO, is reacting with water. G is written after CO, and then after hydrogen also G is there. G is representing gaseous state at 340 atmospheric pressure. Whatever the reaction conditions will be there, they are always represented at the above or below of the arrow. Then L represents liquid. Here CH3OH. Methanol is present in liquid form. Now the next equation, 6CO2 will react with 12 molecules of water in presence of sunlight and chlorophyll to give glucose and glucose, oxygen and water. AQ represents aqueous. When something is in water form, aqueous form, or mixed with liquid, we call it as aqueous. So here we got this, they can make one more question. So here you can write like how a chemical equation be made more informative. For that you need to write like by giving the states of the reactant and product, whether they are liquid, gaseous, solid. We can make the chemical equation to be more informative. Then why photosynthesis is called endothermic reaction. So this can be one of the important question where you need to write as during photosynthesis sunlight is added. So photosynthesis take place in presence of sunlight. So heat is taken in. So thus the reaction is called endothermic reaction. Now two kinds of reactions are there. One is endothermic, other is exothermic. The type of reaction where heat is taken in is called endothermic, and where heat is given out is called exothermic reaction. In the next session, we'll discuss out with the question answers and all. Now coming to the types of reactions quickly. The first type is called combination reaction, where the two simple substances combine to form complex is called combination reaction. You can see here CaO is reacting with water. CaO is called quicklime. Quicklime reacts with water to form slaked lime, CaOH whole twice plus heat is generated. Here the reaction is of two types. As heat is given out, it is exothermic reaction. Along with that, simple substances combine to give complex one. So it is a combination reaction. So what is combination reaction? When simple substance combine to give complex is called combination reaction. Now one more example of combination reaction, CaOH whole twice react with carbon dioxide to form CaCO3 plus water. Now the next reaction is decomposition reaction, where the complex substance will decompose. Here you can see that FeSO4 is getting decomposed to Fe2SO3 plus SO2 plus SO3. When complex substance decomposes to simple one is called decomposition reaction. Decompose means when it will split into simple. It's called decomposition reaction. Now the next one, CaCO3 on heat, it convert to CaO plus carbon dioxide. Here on heating, so when heat is taken in, is called endothermic reaction. They can ask all the questions, whether it is which type of reaction. You need to write all, like whether it is decomposition or endothermic reaction. Now decomposition reaction can be carried in three different ways, that is in presence of heat, then in presence of light, or in presence of electricity. Then we call it as by different names, which can be a long question. If the decomposition is carried by heat, we call it as thermal decomposition. As for heat, we use thermal word. If the decomposition is carried in presence of light, is called photodecomposition. If the decomposition is carried in presence of electricity, then it is called electrodecomposition. With example, you need to prepare for that. Okay, I'll be preparing one more detailed video where we'll go in detail with all the things. The next one is precipitation reaction. So here PbNO3 whole twice on heating will form PbO plus NO2 gas is released and oxygen. Here for the CBSE board they can ask like a brown color gas is released while decomposition of lead nitrate. What is that gas? Identify. So that is nothing but nitrogen dioxide. Now the next one, they have given the electrolysis of water. So how the water get electrolyzed? Electrolyzed means in presence of electricity, splitting of the water. So water will split into hydrogen and oxygen by passing electricity. So it is called electrolysis. Lysis means breaking down in presence of electricity. So it is called electrolysis. Now the next decomposition is carried in presence of sunlight. You can see here, in presence of sunlight, barium or the silver chloride will split into silver and chlorine. So here, when the splitting is done or when the decomposition is done in presence of sunlight, we call it as photodecomposition. So as I told, three kinds of decomposition is there. The first one is photodecomposition, second one is thermal decomposition, and electrodecomposition. Three varieties of decompositions are there. Now the next one, coming to the next topic, both the examples you need to prepare, AGBR and AGCL. Next here, displacement reaction. What is displacement reaction? Displace means when high reactive substance displaces the less reactive substance from its salt solution is called displacement reaction. Here you need to represent like high only can displace the less reactive one. So high reactive is displacing the less reactive from its salt solution. Here we have taken copper sulfate solution, which is blue in color, and iron nails are dipped in that. So when in copper sulfate solution, iron nails are dipped, after keeping it for some time, the iron nails, you can see here, iron nail will get rusted, like iron is getting displaced from it, whereas the copper sulfate solution will fade its color. So this indicates that it is no more having copper. Copper from the copper sulfate solution will displace by iron from the iron nail. So as here displacement is done, we call it as displacement reaction. Different examples are given which you need to read out, like Fe plus CuSO4, FeSO4 plus copper. You need to learn activity series, though it is not given in this chapter. Activity series you come across in chapter number 3. Once you memorize activity 3 series, there they will make the question like they will give an equation, is it possible or not. So from activity series, if the element is at the top of the another one, like copper sulfate and iron, when we compare, iron is more reactive than copper sulfate. In the reactivity series, it comes above copper, so it can displace copper. If the element is not stronger, it will not displace. So to identify that, you need to learn activity series. Now after that, the next topic we are having is oxidation and reduction reaction. Okay, double displacement is also there. Double displacement, when both the ions will exchange, we call it as double displacement. Like here, Na2SO4. So here Na2SO4 plus BaCl2, it forming BaSO4 plus NaCl. So both are getting displaced. Here the definition is given, you can go through with that. So definition will start from here. Exchange of ions between the reactant is called double displacement. So an exchange of ions is last line. Exchange of ions between the reactants are called double displacement. Next is oxidation and reduction reaction. Addition of oxygen is called oxidation reaction. So copper is getting added with oxygen to form copper oxide, and the same way copper oxide is reacting with hydrogen to form copper and H2O. Removal of oxygen is called reduction. You can compare both. First reaction, when oxygen is added, is called oxidation. In second reaction, when hydrogen is replacing oxygen, then it is called reduction reaction. And sometimes in reactions we find that both oxidation and reduction taking place simultaneously at a time. So you can see copper oxide is reacting with hydrogen to form copper plus water. So here copper oxide, from copper oxide oxygen is removed. Copper oxide got changed to copper. In the example you can see copper oxide changed to copper, which is reduction because oxygen is removed, and oxygen is added, so it is getting converted to water. Oxidation has taken place. So like that, few examples you can practice out. Both the definitions are important. Now the last two topics of this chapter, corrosion. Corrosion is nothing but oxidation of the metal. So here different words we use for different gases are there for the different elements. Like for iron, it reacts with oxygen to form corrosion. It get corroded, which we call rusting. But in case of copper copper react with carbon dioxide. These three you need to remember very nicely. Copper react with carbon dioxide to form copper carbonate. Iron react with oxygen to form Fe2O3. Then the last one, silver react with sulfur to get tarnished, which is called corrosion. Tarnished means their color will change, they will get decolorized. Now rancidity. Rancidity is oxidation of food. When any oily substance is kept in open, they get softened, or after some days they will smell like oil. So this property is called rancidity. Now they will ask like define rancidity and how the rancidity can be prevented. Rancidity can be prevented by keeping the food articles in airtight container. So that is one of the way. Or it is flushed with nitrogen. So generally this chips manufacturer, they flush out nitrogen in chips packets so that it will not get rancid. The rancidity can be prevented, or oxidation of food can be prevented. The chips will not become soft. So out of that paragraph they can ask what is rancidity, how it can be prevented, or what are antioxidants. Give some example. So that nitrogen oxide will come. Nitrogen will come, sorry. Nitrogen oxide is not there. Nitrogen is antioxidant. So this is the overall view. If you want to have the complete explanation of the chapter, please comment me in the comment section, so that once I'll go in detail with line by line explanation where you can get much more perfect knowledge along with discussion of the exercise and in-text questions, so that you can prepare well for your exams. So those who attended today's class, lot of thanks to them. Thank you for watching my video. For more such videos, please support and like and subscribe and share my videos so that I can come across with much more wide knowledge. Okay, thank you.